If the European city gave us the dense carpet of urban perimeter blocks, the American city gave us the skyscraper. So when we were recently asked to design a Scandinavian skyscraper, it was almost like designing a contradiction in terms. So as a starting point, we looked at the structural challenges of a tall building. So for a normal building, the primary structural load is the gravity load, the fact that Newton told us that everything drops down. But beyond a certain height, the primary structural load shifts from the vertical forces of gravity to the horizontal forces of the wind load. And that's why most skyscrapers tend to be square in plan, so that for any given wind load, you have an equivalent foothold. As a result, the American skyscraper is this very tall building with deep floor plans. It increases the distance from the core to the facade so much that the building becomes dependent on mechanical ventilation and electrical lights. So it's no coincidence that the American skyscraper was invented at the same time as the elevator, electricity and mechanical ventilation. So we thought, as a new idea, what could be sort of specifically Scandinavian about a building would be to design a skyscraper so slim that it has an abundance of natural daylight and it's completely naturally ventilated. And the result is this like tall monolith, but it is as structurally complex as it is visually simple, because where you have the biggest wind load, you have almost no foothold, and the result is this unstable monolith. So like after dealing with the issue for quite a while, we came up with this idea, this typology that we call the Escher tower, together with our engineers. It's essentially 3 square towers that merge into a single slab at the bottom and at the top. The central tower is completely straight, going all the way from the top to the bottom with the elevators. And the 2 other towers, they change places at a 45-degree angle. As a result, you get a shape where you have the biggest wind load, you also have the biggest foothold. And where you have almost no foothold, you have almost no wind load. So essentially it's a shape that is proportionate to its structural performance. We call it the Escher tower because we found this drawing by the Dutch artist M.C. Escher. He's known for making these sort of impossible perspectives. And it's essentially the same design. It's 3 square towers that merge into one, facing one way at the top and the other way at the bottom. But where the tension of Escher's art is in the fact that it looks prospectively feasible, but it's in fact impossible. With the Escher tower, it's almost the opposite story. Depending on where you see it from, it looks surreal, like changing from a cup to a twisted slab, to a bottle, to an hourglass. So it looks surreal, but it is essentially a creation of common sense. So as a final test to see if the theory holds in practice, I'm going to perform a little wind tunnel test in our own little office.